Welcome to our overview of motor and drive measures webinar. It's currently 2 p.m., so let's get started. My name is Portia Baldet, and I'm the ESB Marketing Manager from the Enerva and Summerhill team. Enerva and Summerhill are supporting Emissions Reductions Alberta with the design and execution of the Energy Savings for Business program. Thanks for joining us. Before we get started, let's go over a few housekeeping items. There are quite a few people attending today's webinar. As such, all microphones have been muted to avoid interruptions. Throughout the presentation, you can submit questions to our team through the webinar control panel's questions section. We will answer those questions during our Q&A period at the end of today's webinar. If you are having technical difficulties, please email Amanda at info@eralberta.ca and we'll do our best to help. If you can't resolve your technical issues or need to leave early, we'll be posting a recording of this webinar on the ESB program website. It will include both the presentation and the Q&A session. Today, we'll begin with a brief program overview, including eligible measures categories, and then we'll review eligible motor and drive technologies, program requirements, and applications. Our team will also suggest some strategies to allocate costs between materials, labor, and design for projects with multiple measures. We'll then end the presentation with a Q&A period. Today, Alison Mostowich, Emission Reduction Alberta's Manager of Outreach and Engagement, will provide a little background on the ERA and ESB program. Then my colleague Patrick McMahon and Surya Narcia will jump in to guide us through motor and drive measures. Now let's get right into it. Here's Alison to kick off today's presentation.
Thanks, Portia. Hello, everyone, and thank you for joining us today. Reducing greenhouse gas emissions while supporting the economy benefits everyone, and ERA's vision is anchored in the belief that our success is measured in both economic and environmental terms. Emissions Reduction Alberta has been investing in Alberta technologies and companies since 2009 to reduce emissions and grow Alberta's economy. Our investments help innovators develop and demonstrate GHG reducing technologies that lower costs, improve competitiveness, and accelerate Alberta's transformation towards decarbonization. We have worked across sectors and have recently broadened our scope with the Energy Savings for Business program. This program will accelerate the adoption of commercially available technologies that will help businesses cut costs and reduce emissions. Learning from previous programs with similar scope, we have adapted the program to be more streamlined. We know time is money to Alberta businesses and are committed to fast turnaround times. For standard applications, this can be as quick as 2 days. The program has been designed to reflect the realities of the pandemic. Incentive payments will be made electronically, and all program materials are available in digital, downloadable format that can easily be printed by contractors or participants. We have also expanded the measures list to include categories that have not been offered previously, such as geothermal and compressed air. We've also made sure to include measures that are accessible to all businesses, like ceiling and wall insulation, refrigerated case covers, more efficient motors, lighting systems, and high efficiency windows. We will have over 300 measures to offer in this program. Motors and drives are an important component. Energy costs can be high because of an inefficient system design and motor operation. Equipment that is not properly matched to the requirements of the application tend to require more maintenance. Effective motor and drive system management can reduce operating costs, improve performance, and increase reliability. In the coming days, we will be hosting more webinars like this one to help guide contractors and applicants through the process. Webinars on solar PV and lighting system and control measures will be held tomorrow and Thursday, respectively. To register, please visit eralberta.ca/ESB. We're happy you could join us today to review motors and drives. I'll pass it off to Patrick and Surya to take you through how to apply for this category of incentives.
Thanks, Alison, and welcome to all attendees. Today's webinar, Motors and Drives, will cover 3 measure types: variable frequency drives, high efficiency motors including ODP and TEFC enclosure types, notched and synchronous belts. I'm joined by Surya Narcia, who will help me understand these measures and provide escalated technology and application related support through program delivery. The first measure we'll cover within the motors and drives category is the variable frequency drive. Surya, what's a variable frequency drive?
Hey, Patrick. A variable frequency drive, or VFD for short, is simply an electronic device that matches a motor speed to the needs of a mechanical load. The mechanical load can be a pump, a fan, a blower, and so on. Many of these systems require some sort of flow control, and this is often done by throttling the flow with a valve or recirculating some of the flow, or sometimes with some kind of mechanical speed reduction. A VFD accomplishes flow control by altering the speed of the motor directly.
All right, so can we save energy using a VFD?
Absolutely. VFDs can save lots of energy. For example, by replacing a throttle valve in a pump system or a damper in a fan system, you can save energy. A throttling valve or a damper cause mechanical restriction to reduce flow, but the motor is still running at full speed. It's kind of like keeping your foot on the accelerator and then using the brakes to control your speed in the car. A VFD can precisely match the motor speed to the mechanical needs. On that slide, you can see the equation for the affinity laws, where speed, or RPM, have a cubic relationship with power. So if you reduce the speed, you can get large power savings. While this is a theoretical situation, in the real world, it's probably more like a 2.5 exponent, not the cubic, depending on the situation.
It's amazing that you can save that much. Is there anything that needs to be considered when you decide to use a VFD?
This is a very important question, Patrick. First, you should work closely with your contractor or engineer. There are many factors that need to be considered. I'll point out two things. First, your motor should be rated for VFD application. You can ask your contractor if the existing motor can work in the long term with a VFD. Another thing that you should consider is harmonics. The power electronics from a VFD will produce harmonic frequencies into your electrical distribution system. So you should talk to your contractor or engineer and determine if a harmonic filter is appropriate for your application.
That's great advice. So how does the VFD know which speed to run at?
So for systems that already have some kind of control strategy to adjust the operating point, you can often use the same inputs for the VFD. And the VFDs can be programmed to accept various kinds of inputs. So here is another excellent opportunity where customers should talk to their contractor or engineer to determine the appropriate control strategy adjustments.
This is interesting technology, and I'm sure there's lots of opportunity for application throughout commercial and industrial processes in Alberta. Surya, can you highlight specific program considerations required for VFDs?
Sure. So this incentive package is provided for VFD implementation on motor-driven systems. Only retrofit applications are eligible, which means new construction is not eligible. The incentive amount is based on the motor horsepower, that is, on the motor where the VFD will be installed. The incentive is paid at the rate of $125 per horsepower. So for example, if you have a 10 horsepower motor, the incentive would be $1,250, provided that there are not any incentive caps applied. And we are going to be talking about the caps later on in this webinar.
When it comes down to adding the measure to the application process, as a participant or as a contractor, if your customer has enabled your participation, here are the requirements that you'll be asked to provide when adding a measure to an application. The first step is to work through the drop-downs by selecting motors and drives from the measure category drop-down, then VFD from the measure type, and the final selection will be the specific measure corresponding to the measures list. You'll need to consider the type of application, either a fan or a pump, and the power of the motor that will be controlled by the VFD. With the measure selected, the participant or contractor connected to the project will identify the quantity of variable frequency drives. The balance of the questions regarding the measure itself relate to the fan type, axial or centrifugal, the drive type, direct or driven, the centrifugal blade type, forward curved, backward curved, radial tip, among others, or not applicable if not applicable. Appropriate options for an axial blade type are listed, or not applicable if updating a system with a centrifugal blade. There's a required text field to add a description of the existing flow control for the fan, and the same for the full load CFM of the fan. For non-fan applications, just enter 0, then upload a photo of the nameplate placard of the fan that will be controlled by the variable frequency drive. From the nameplate of the fan, it should be relatively simple to document the fan manufacturer and model, horsepower, then add the estimated annual operating hours of this motor. A specification sheet of the VFD being installed will need to be added, dragged into the gray area below the prompt for the estimated annual operating hours. Before adding the costs, you'll note that the estimated emissions benefit of the measure installation will be summarized. The final inputs for the measure definition relate to cost, the equipment and material cost, labor cost, and design cost. With all that information, click the prompt for Get Calculation, which will flag any missing field or fields, and also populate the fields that had been previously indicated as calculated value. This will include the measure incentive based on the details provided through measure definition and against program rules. Have a scroll through the submission to confirm the details as entered are correct. If you see something that needs to be changed, click Edit Details, or if it is complete in reflecting the installation, click Add Measure. The next measure in the motors and drives category we'll cover are the high efficiency motors. Surya, can you tell me what you mean by a high efficiency motor?
Sure. High efficiency motors, they're also called premium efficiency motors. They were introduced by NEMA in 2001. NEMA, the National Electrical Manufacturers Association, which is the largest trade association of electrical equipment manufacturers in the US, advocates for the industry and publishes standards. This premium efficiency motor standard, which NEMA adopted, requires that the motor meets or exceeds a set of minimum full load efficiency levels.
So what makes the motor high efficiency?
Well, it's the way it is engineered. Premium efficiency motors use high quality materials. They're designed better and have better manufacturing tolerances. The main efficiency improvements are lower resistive losses, reduced slip, and reduced losses in the windings. These are all possible because of better materials and better construction because of better engineering.
Interesting stuff. So what does the program offer in terms of incentives?
So this program requires that, first of all, the new motor must meet the NEMA premium efficiency guidelines. And the incentive covers a fixed dollar value per horsepower, and it goes up to 500 horsepower. So we've published the measures list, and the incentive for each size of motor is actually indicated up there. We recommend everyone to take a look. And we recommend customers to actually work with their eligible contractors to determine the best motors to replace with premium efficiency motors. There are many considerations, and it's best to assess your situation.
So a process where a high efficiency motor would improve process efficiency and is pursued by the building owner or leaseholder requires a pre-approval application. In identifying the measure inside the application portal, the participant or contractor working on behalf of their customer will identify the motors and drives measure category from the first dropdown. For the high efficient motor measure type within the motors and drives category, select the appropriate type based on its enclosure, ODP or TEFC, and in the next dropdown, choose the specific measure that reflects the motor and its horsepower as it appears on the eligible measures list. Measure-specific information is then required. The quantity of motors of the same horsepower installed, the estimated operating hours of the motors, or an average of each similar motor. A photo will be required of the nameplate of the existing motor, then noting the existing motor's horsepower, efficiency, and age. Identification of the motor as a dual or single speed, and if the existing motor was previously rewound, will be required. The application form will require the definition of the type of equipment driven by the motor, fan, pump, gearbox, or other. The efficiency of the new motor and speed is required, and a spec sheet for the new motor needs to be uploaded. Before adding the costs, the estimated emissions benefit of the measure installation will be summarized. The final inputs for the measure inclusion relate to costs, equipment and material costs, labor costs, and design costs. With all that information inputted, click the prompt for Get Calculation. This will flag any overlooked fields and populate the fields that had previously been indicated as calculated value. This will include the measure incentive. This is a great opportunity to scroll through the submission to confirm the details are correct as entered. If you see something that needs to be changed, click Edit Details, or if it is complete in reflecting the installation, click Add Measure, and you'll return to the Measures and Project Summary phase of the application. The last measure type within the motors and drives category is notched or synchronous belts. That's a mouthful. How common are these, Surya?
Really common. About a third of electric motors and drives in the industrial and commercial sectors actually use belt drives.
Can you tell me about the different kinds of belts used in commercial and industrial settings?
Sure thing. Belts are common components of mechanical equipment, and the most popular one is traditionally known as the V-belts. And the basic type is either called standard V-belt or smooth V-belt. These belts run smoothly, low noise, they require less maintenance, but they can be prone to slippage as they wear with time. And this can result in significant energy losses in the drive system, in addition to increased vibration and potential damage to components. Notch belts, on the other hand, have grooves or notches that run perpendicular to the belt's length, as you can see in the picture, which reduces its bending resistance. And they can use the same pulleys as the standard V-belts. And the other type is called synchronous belts. They're also called cogged or timing belts. They are tooth, and these ones, they do require a mating grooved pulley. Synchronous belts have the added advantage of maintaining tightness at high torques. They're almost slip-free, and they can operate in wet environments as well. Yeah.
How much more could a change for a belt system like that generate?
So typically, you will see they would be in the range of 2 to 3% efficiency gain. So if you replace with a notch belt, you'll be in the 2% efficiency and a little bit more with a synchronous belt. While 2% may seem like a small value, but when you consider 6,000 hours of operation annually or even more, the savings become really significant. And the more such drives you have in the plant, the more savings can be achieved.
Could you tell us about some of the key considerations of this measure category within the context of the Energy Savings for Business program?
Absolutely. So there are two categories for the incentive. It's very straightforward. So the program offers $20 per belt for under 6 feet of length or circumference, and $40 for 6 feet or longer. And typically what is recommended is to conduct a survey of the belt drive system and gather as much operating information and make an assessment where they would be required to be upgraded.
So the application for the notched or synchronous belt retrofit starts, as in other examples, after the Add Measure prompt from within the application and selecting the Motors and Drives measure category. Next, you'll select the notched or synchronous belt retrofits from the measure type, and then for the specific measure, identify it based on its length between pulleys. You might start to identify a theme in the next set of questions that require the input of the number of these measures to include through this application, and the estimated hours of operation, or average for multiples, of the belt system. The submission requires a photo of the motor nameplate driving the belt and identifying the horsepower, the existing efficiency of the drive motor, and the age of the existing motor. Again, you'll see the estimated emission savings before adding the costs. Costs will include material costs, labor costs, and design costs. With all that information inputted, click the prompt for Get Calculation, which will flag any overlooked fields and populate the fields that had previously indicated calculated value, including the measure incentive. Again, this is a great opportunity to scroll through the submission to confirm the details as entered. And if you see something that needs to be changed, click Edit Details. Or if it is complete in reflecting the installation, click Add Measure, and you'll return to the measure and project summary phase of the application. For measures within the motors and drives category, the maximum eligible measure incentive is 50% of the eligible project costs. Where a project has multiple measures, costs may need to be reasonably allocated to each measure. I'll showcase the value of this and provide a suggested process with an example. Let's imagine a facility that is installing VFDs for 2 of their HVAC fans, a 25 horsepower motor and a 15 horsepower motor. You can see example costs for this project on the screen, including the equipment costs, labor costs, and design costs of the project. You can also see that the potential incentive for each eligible measure. In this case, the incentive for the VFD is calculated at $125 per motor horsepower. Note that with an incentive limit of 50% of the eligible project cost, if only the equipment costs were included for either of the measures, the incentive would not be maximized. In this case, the VFD associated with a 25 horsepower motor has a cost of $6,000, and if included in isolation would be limited to a $3,000 incentive, but is eligible for a $3,125 incentive based on the prescriptive rebate rate. This should highlight the need to fairly allocate costs across all measures included in the project application. For the benefit of the participant, a fair allocation of the labor costs and design costs should be applied to each individual measure. In the example, the labor and design costs are allocated evenly between each measure, illustrated in the table, and the participant is eligible for the maximum incentive for each individual measure. To support prompt review of the pre-approval application, it's recommended, but not required, to provide a summary breakdown identifying how eligible costs are or were allocated across the measures included in the project application. Complete applications lead to prompt approvals. Helping the review team understand how you've approached this application, especially in this context, can help everyone get to project execution faster.